My name is Robert Kosowski. I'm an expert in flame retardants, having worked at DuPont for 35 years in R&D, and I've invented a flame retardant that can stop the progression of a wildfire, which we want to demonstrate today. Now, these are coated sticks, and you can see that you can hardly tell there's any material on it, and these are uncoated. So we're going to stick them in here and see how they compare when they burn. These are 1/2 inch and 3/8 inch. Oh. Okay. And we'll be able to tell which ones are, and keep it on the flame now the whole time. And we see the uncoated is beginning to burn already. And I did these just in random fashion. And we'll take now a few minutes and to see how they behave. And that's the 1/2, 1/2, and this is the 3/8 and 3/8. And the whole point of stopping a forest fire, that only vapors burn. So you have to get stop the progression of vapors. The coating forms a thin crust, and that stops the vapors from coming out, separates the fuel and the fire. And once you do that, you greatly slow the rate at which things burn. So we see this is burning at a rapid rate, whereas the coated material is burning very slowly, if at all. But everything is going to burn eventually. But the whole point is to take a very long time to burn. And that's what a rain does for one, a steady progression of rain. It just it keeps the a wet surface on it so that it cools the fire and stops the progression. And this obviously is the uncoated here. How long have they burned now?
2 minutes, 42 seconds.
Okay, so after 2 minutes, 42 seconds, we see that our uncoated are, getting burned pretty badly, whereas the coated material with no embers, and the reason we call it no embers is because it stops the formation of embers. And embers is how fires progress. And so finally we see a little bit of burning at the bottom, and that's okay. You want it to burn very slowly, which is the whole point. Hopefully we can go about 5 minutes and we'll see how things look after 5 minutes. It's a person who doesn't want to wait forever watching a video on YouTube. Let me get this one a little further in. And this is a really hot fire. I mean, I'm standing a few feet away and really sweating. And we see the formation of embers on the uncoated. And when these go flying in the wind, you're going to have hot spots spraying up, and then those are going to keep the fire going and progressing very rapidly. And that's what you need to stop. I mean, look at that ember there. It's really hot. And right next to it, we have what we want, a very slow burn of the fuel. And this is already getting to break off. Yeah. Every time I do this experiment, which is probably about 100 times, I just can't believe it works so well. And we're really having a lot of difficulty trying to get fire departments to try this stuff. And it's environmentally friendly. EPA has approved testing. Now people should recognize that every acre of ground that burns creates about 11,000 pounds of pollution. And we're going to be putting this on spraying it on fires at about 50 gallons per acre. That's on good sized foliage. And that's about 350 pounds per acre. And it's a fertilizer, so no harm done to the environment. We're putting it on at about a teaspoon per square foot. Let me just push this one over. Maybe it'll get, I mean, it's amazing how well it's doing. I mean, this is the first time I've done this test. How many minutes we had in it?
6 minutes and 9 seconds.
Well, I mean, it's time to put more wood on.
So this is the first time you've had it hanging down, but you've done
Yes.
various other experiments, right?
Yes, and they all work well, but a fireman asked me about what this would do in terms of a small test inside. This is one you could do inside of a firehouse, which is what we're going to suggest.
Yeah, this is very interesting.
For non-believers to do this. But, I mean, you know.
And if somebody would ask for a sample, would you be willing to send out a sample?
Oh, absolutely. But they have to, EPA is concerned that it shouldn't be like homeowners. They want well-qualified firefighting kind of people to get samples. But for firefighting people, yes.
And how can they find more information about this?
On my website, pnsolco.com.
Can you spell that?
P is in phosphorus, N is in nitrogen, S is in Sam, O is in Oscar, L is in Leonard, then CO for company.com. And we have more videos as well. Well, at this point, I'm going to stop because I'm sure you're getting bored there, although we're going to watch it to put more wood on the fire and just see what happens longer term.
Okay.
Thank you very much.
Thanks for showing us this video, Robert.